Hello everybody, here we have another 1D kinematics problem. In this instance we are focused only on the y-axis rather than the x. So the problem states, a person throws a ball upward into the air with an initial velocity of 15 meters per second. Calculate how high it goes and how long the ball is in the air before it comes back down. Now to analyze what this is asking, it is basically saying that there is a ball, is thrown upwards, it reaches some height, it comes back down, and that's about what happens. This would be the height that we're looking for in A, and the time would be how long it takes to go up, so here and here. So we have two separate times in that instance. Now, if we look at the equations, they're a little different than in the x direction because we have to account for gravity. As in these problems, acceleration is always going to be related to gravity. Gravity is constantly pushing down on whatever is going up. So that is something to keep in mind. Generally, you'll see the value to be 9.8 meters per second squared. And I wrote negative in this instance because in almost every instance, if you think about it in an xy plane, gravity pushes down on the y-axis. So this is something to keep in mind. Now, for A, if we look at the equations, well, actually first let me just write down everything that we have. So we have v0 is equal to 15 meters per second. We know acceleration is going to be equal to negative 9.8 meters per second squared. And there's also one other thing to keep in mind, that when you get to the highest point at this line here, this is when the velocity is going to be 0. You can think about the ball reaching that height, stopping, coming back down. So in this problem, the velocity is 0 meters per second at the highest point, which is what we are looking for in part A. So if we write down the equation, v squared is equal to v0 squared plus 2ay. We can plug everything in remember this is 0, v squared is 0. Well, v is 0, so v squared is also 0. 15 squared plus 2 times negative 9.8 y. We can move things around. We have this is negative over here, so let's just add it to the other side. So 2 times 9.8 y is equal to 15 squared. And then 15 squared divided by 2 times 9.8 will be equal to y. So what does that equal? That will equal 11.48 meters. So that would be the answer to part A. That is the height over here, the highest point at which it goes. Now for part B, we wanted to know how long the ball is in the air. Now we can use the other equation for this. Y is equal to y0, because we now know what y is, plus 1/2 at squared. So now for the next part, we have to find the time at which the ball was in the air. So the easiest way to do this is to realize that, if I draw a diagram again very quickly, so when it goes up and it goes down, and you think about this on being on a xy plane, both of these instances, now this is obviously not correct because it's in the same x plane at both instances, so you can imagine that they're both at this point. But you can notice that at both of these instances, y is equal to 0. So here and here, y is equal to 0. So that would mean y is equal to 0, the height of y, and y0 is equal to 0. So that would make things much easier because we can just say 0 is equal to 0 plus, it's 15t plus 1/2 negative 9.8 t squared. Now it's just a simple little algebraic expression. Let me just rewrite it again. 15t plus 1/2. Let me just make it negative now. Move the negative outside. and move it to the side. So it's pretty much the same as what we did in the previous part. So 1/2 9.8 t is equal to 15, and then I can put it here. So 15 divided by 1/2 times 9.8 will be equal to t. So what is that? 15 divided by 0.5 times 9.8, which is equal to about 3.06 seconds. So that is how to solve this kind of problem. I hope it gave you a little better understanding of how to work with one-dimensional kinematics problems in the y direction.